We'll now begin our discussion of section 3.3 and learn about other common functions. We begin by discussing functions of the form ax raised to the n power. We already know the graph of a function of the form f of x is equal to ax to the first. Now we know that typically we do not write the first power. We simply assume that to be the case. So we know that this is a linear graph. If the a value was, for example, 5, we would be graphing the line y is equal to 5x. So regardless of what the a value is, we know that when we go to graph this equation, it is going to graph a straight line. So I'm going to sketch it just like this. We also already know what happens when the power is 2. So if we have f of x is equal to ax to the second power, then we know that that graphs a parabola. So what we now want to consider is what happens when we increase the exponent, when our function becomes ax to the third or ax to the fourth. We actually have two cases that we want to consider. One case is where the exponent is odd. All right, so that's what we're seeing right here on this first case. So let's talk in a little more detail about that first case. So if the exponent is odd, so we know that if it's to the first power, we get the linear graph. If it is to the third power, then the graph starts to take on this shape. If we are graphing to the fifth power, then the graph has the same shape, but it becomes more narrow. If we were graphing to the seventh power or a higher odd exponent, we would have a graph that had the same shape as this, but would be more and more narrow as we continued. So we want to keep that in mind, that that is the progression for the odd powers of x. We start with a line, then that line moves into this sort of S-shaped curve, which gets more narrow as we increase the exponent. The other case is if the exponent is even. So we've already said that if our exponent is 2, we know that we graph this parabola. So what happens if the exponent increases to 4, which would be our next even number? And so in that case, the graph is similar to the first one, except it's going to be a little more steep, and we're going to see some flattening out around the vertex. So maybe a little more like this. And if we increase the exponent again to, say, x to the 6th, we would expect that to become even more steep and more flat around that vertex. And we would continue in that manner, increasing the exponent to an 8, increasing the exponent to a 10, seeing the graph become more steep with each increase and more flat along the vertex. So keeping that in mind, our first example asks us to graph f of x is equal to x to the 4th over 5. Now, what we want to keep in mind here is that this function is really 1/5 times x to the 4th. And we know what the graph of x to the 4th looks like because we've already kind of sketched that one out. We know that it's a parabola with some steepness showing on the sides and a little flatness across the bottom. So the only thing that I need to do now is to determine the effect of the 1/5. So what does the 1/5 do? The 1/5 causes the graph to compress vertically. So we want to keep that in mind, but the easiest way to do this graph is going to be to actually do a quick table of values. We do have in our head that we're going to get this parabola, so we know where we're going with this, but let's do a table of values very quickly, get a couple of points on here so that we can finish up this sketch. All right, so for example, I might try -1 and I might try 2. All right, and we're going to go back to our function, which was f of x is equal to x to the 4th over 5. We're going to first plug in the -1, so we would have -1 to the 4th over 5. -1 to the 4th is 1, and so our answer would be 1/5 there. And you can see that that's already plotted for us on the graph. -1 and up a 5th would plot right about here. And then we'll do the same thing with 2. So we'll plug a 2 into our function, making it 2 to the 4th over 5. 2 to the 4th is 16 over 5. And again, you can see that that is also done for you. Over to 2, 16 over 5 is 3 and just a little bit. 1, 2, 3, and just a little bit would put me here. And once you have a couple of points, knowing that it's going to graph this parabola, we can go ahead and trace in what this sketch of that graph is going to look like. All right, our part B said to graph the function g of x is equal to -x to the 3rd. And so again, we already know that x to the 3rd graphs this is our first odd one, so it kind of starts in on that S curve, but has some width to it there. And so what does the negative do to that graph? The negative causes the graph to be reflected over the x-axis. And again, it may be helpful for you to plot a couple of points, even though you know basically what the graph looks like and you know it's going to have a reflection over the x-axis. It may be helpful to plot a few points to help you draw it. And so you might say, okay, let's take our graph and let's plot, let's do -1 and let's do +1. And so our function was -x to the 3rd. So we'll plug in -1. Now remember, you're putting -1 in for the x. This negative stays on the outside. We do our exponent first. So -1 to the 3rd would be -1. And then we're going to have a negative on the outside, making that +1. Then we're going to do the same thing for f of +1. We would have -1 to the 3rd. 1 to the 3rd is 1. And we apply the negative, we get -1. And so again, you have two points now that you can plot. -1, +1 is here. +1, -1 is here. You know that basically this graph has this sort of S-shaped curve, but it has been reversed because it has flipped across the x-axis.